It's an honor to speak to you today. Today, we're going to talk about the infrastructure bottleneck and why compute is the easy part. The global race to build digital infrastructure is accelerating rapidly. Around the world, new compute deployments are being announced almost weekly. Facilities measured not in megawatts, but in hundreds of megawatts, and increasingly gigawatt scale clusters. In some cases, organizations have secured compute capacity before confirming power delivery timelines. The result is infrastructure racing to catch up with decisions that have already been made. There is a reality that most organizations are overlooking. Compute doesn't fail because of processors. It fails because of infrastructure. Land readiness, power availability, water and cooling capacity, fiber connectivity, and something I refer to as constraint latency. Constraint latency is the delay between when compute is ready and when infrastructure is not. Transmission upgrades take years. Utility interconnection queues continue to grow. Critical electrical equipment carries lead times measured in quarters, but sometimes years. In the boardroom, the conversation is about scaling up compute. Out in the field, the conversation is about how long infrastructure will take to catch up to the demand. The gap between those two conversations is where digital infrastructure programs stall. What is the infrastructure bottleneck? Understanding the bottleneck begins with scale. 10 years ago, most enterprise data centers operated in the 5 to 25 megawatt range. Hyperscale facilities expanded that to roughly 50 to 100 megawatts. Today, we're seeing programs targeting 300 megawatts, 500 megawatts, and in some cases, gigawatt scale deployments. At this scale, the challenge changes. The limiting factor is no longer how quickly servers can be installed. The limiting factors become land development, power systems, water and cooling systems, connectivity networks, and supply chains. The problem shifts from technology deployment to infrastructure execution, which leads to a simple reality. Servers scale in months. Infrastructure scales in years. The difference in timeline is where the bottleneck begins. Constraint latency changes everything. Most organizations think about infrastructure constraints in terms of capacity. The deeper issue is time. Constraint latency is the delay between when compute capacity is ready and when infrastructure actually delivers power, cooling, and connectivity. At scale, that delay becomes significant. Transmission upgrades may take 3 to 5 years. Large electrical transformers often require 18 to 36 months. Interconnection queues in some regions extend beyond 2 years. When these timelines are not accounted for early, deployment schedules shift to the right. What begins as an 18-month deployment becomes a 3 or 4 year infrastructure program. And during that delay, capital is already deployed. Equipment is already procured. And in some cases, facilities are partially built. But without power, without cooling, without connectivity, that capital produces no return. This is how constraint latency creates stranded capital. And it doesn't stop there. When infrastructure lags, schedules slip, contracts get renegotiated, and downstream dependencies begin to stack. What was designed as a synchronized deployment becomes a series of disconnected timelines. And once that happens, recovery becomes significantly more difficult. This is constraint latency. and it is now one of the defining challenges of large-scale digital infrastructure deployment. There is another factor increasingly shaping large-scale digital infrastructure deployment, and that's community environmental expectations. Across Europe and increasingly around the world, communities are asking important questions. How much power will these facilities consume? How will water resources be managed? What impact will large-scale digital infrastructure have on local grids and surrounding communities? These questions reflect a broader shift. Digital infrastructure is no longer just a technology issue. It is now part of the national energy strategy and community planning. Digital infrastructure has become critical infrastructure. Projects that address energy sourcing, cooling, efficiency, and community integration early in the planning process tend to move forward more successfully. In many cases, responsible environmental planning actually reduces project risk and accelerates deployment. In other words, sustainability and infrastructure readiness are not separate discussions. They are part of the same discipline. Discipline readiness wins deployments. Organizations that succeed take a different approach. They treat infrastructure readiness as a strategic discipline. Power availability is validated early. Utilities are engaged before compute capacity is announced. Cooling infrastructure and water access are modeled before site selection is finalized. Fiber routes and redundancy are secured before construction begins. Supply chain timelines are built into deployment schedules. When infrastructure planning starts early, constraint latency is reduced. When it is ignored, it becomes the dominant factor controlling deployment speed. At this scale, that difference is significant. In contrast, when infrastructure readiness is not managed early, teams are forced in reactive decisions. Temporary solutions become permanent. Cost increase and deployment quality degrades. At scale, those decisions compound quickly. In closing, the next phase of digital infrastructure will not be limited by processors. It will be limited by power availability, infrastructure readiness, and of course, constraint latency. Compute is the visible layer. Infrastructure determines whether deployment happens. Organizations recognize this early will move faster. The race to build compute is visible. The race to build infrastructure is where the outcome is going to be decided. And when organizations finally hit their constraint, they discover something important. Compute was the easy part. Thank you, everyone.